Let's take a look at our next problem in this AP exam prep. And we have the indefinite integral of x times the square root of 3x squared plus 2 dx. And what do you do on this problem? Well, notice that we have x to the second power and we have another factor with just x in it. When you see this, it should just cry out for the one method that we need to use here, which is U-substitution. So anytime you have a variable to one power and another variable and the same variable to one less power, think U-substitution. Try that first. And so what's the first step? The first step is to pick u and then to find what du is. Okay, and so to pick u, we pick u to be the expression with the highest power, which is 3x squared plus 2. And we take the derivative of both sides here and we get 2 times 3 is 6x and dx. So du is equal to 6x dx. But you go back up and look at our problem, we don't have 6x dx, we have x dx. So what we need to do is multiply both sides by 1/6. And if I take 1/6 of 6x dx, then I'll have the x dx that we have in our problem. Okay, so I picked u and I found du. What's the second step? The second step is to substitute for u and du. Or actually, I'm writing for u du and du, but actually we're going to I don't know if it's substitute for or put u in place of, but anyhow I think you know what I mean. And so let's go back up and see what are we going to let's just copy our problem down again, and let's rewrite the radical with a rational exponent instead. It's always a good idea to take any radical you have and write it with a rational exponent. So we're going to write 3x squared plus 2 to the 1/2 power x dx. And we've just rewritten our original problem, and notice I just moved the x from the front out to the end out there. So it now reads like this, and this will make it easier to do our substitution. So notice what we have for u is the 3x squared plus 2, so we replace 3x squared plus 2 with u, raise it to the 1/2 power, and x dx, remember, was 1/6 du. So the 1/6 can come out in front of the integral, and we'll put the du in at the end. And we've done our substitution for u and du. What's next? The next step is to go ahead and integrate our simplified integral. Okay, so we're going to integrate. Let's just rewrite our integral again. 1/6 the integral of u to the 1/2 du, and it's now simple to integrate this. All we do is add 1 to our power. That will bring it up to u to the 3/2. 2/2 plus 1/2 is 3/2, and then divide by the new power, 3/2. And then don't forget, this is an indefinite integral, so you need to put plus c. Okay, we can rewrite this when we're dividing by 3/2. That's the same as multiplying by 2/3. u to the 3/2 power plus u plus c. Okay, and we can simplify this. I can cancel out the 2 and the 6 and simplify it down to 1/3 times 1/3 is 1/9 u to the 3/2 power plus, oh, that looks more like a 6 than a c, plus c. We've completed our integration. Now there is just one more step, and that is to reverse substitute. Earlier we replaced our expression with u, and now we're going to go back and put the expression back in place of u. Sometimes I have trouble with the word substitute, which I'm having right now, but I think I've got it spelled right. Reverse substitute, and so we have now 1/9, and we're reversing back, and in place of u, remember back up here we had, where is it? We had u is equal to 3x squared plus 2. So now any place we see u, we're going to put in 3x squared plus 2. So that goes in right here, 3x squared plus 2, and that's raised to the 3/2 power plus c. And there's our solution. So to just briefly recap, we identified this as a prime candidate for U-substitution, and so we went ahead and picked u. We found out what du was. That was the first step. The second step was to substitute u and du into our integral, and then to integrate with our nice simplified integral, and finally to reverse substitute. And there's our solution again. See ya.